Good morning, everyone. Today, let us discuss the reaction of group 2 elements with air. In the previous class, we did the reaction of group 2 element with water. So we will continue now the group 2 elements reactivity with the air. Like group 1, the group 2 elements react with oxygen or air to form the corresponding metal oxide. Now, if we talk about the reactivity, like in group 1, as we go down the group, the reactivity will increase. First, talking about the reactivity of the beryllium compound, beryllium react with air when you heat the reaction at a temperature equal to or greater than the equal to or greater than 600 degree centigrade. If you keep the temperature below 600 degrees centigrade, this reaction won't happen. However, if you take a very big piece of beryllium and try to react at this temperature, the reaction would be almost reluctant to move forward. However, if you break that big piece into smaller particles like powder, then the reaction would be really fast and it like glows very well as it burns. Okay, so reactivity can be increased by powdering the beryllium metal, then it will react smoothly with air at this temperature to form the corresponding beryllium oxide. If we talk about magnesium, when we did the diagonal relationship at that time, I told you that there is a diagonal relationship between lithium and the magnesium. So lithium also formed, when it reacts with air, it forms nitride. Similar to that, magnesium also, along with the oxide, it forms the corresponding nitride as well. Another important thing that you have to note here is that when magnesium reacts with air, it burns with a dazzling brilliance. So that means it's highly exothermic, and this reaction evolved a lot of heat. And that heat is actually used to start this thermite reaction. Now, thermite reaction is a reaction in which it's a redox reaction which is basically used for welding purposes as well as in metallurgy to extract the metals from their uh, corresponding metal oxides. Okay, so for that purpose, we use thermite reaction. So in order to ignite this thermite reaction, because the thermite reaction won't automatically start. So in order to ignite this thermite reaction, we use the exothermic energy that is released by the burning of magnesium. Okay, so magnesium ribbon, when it is burned, it releases a lot of heat that is used to ignite the thermite reaction. Now, I'll just give you one of the thermite reaction in which basically what you do is you will take Fe2O3, that is ferric oxide, okay, when reacted with aluminium, okay, aluminium metal, it forms corresponding Al2O3 plus the Fe metal is released. This is a highly exothermic reaction, but the thing is that this reaction won't happen as such. You have to ignite this reaction. For the ignition of this reaction or to jumpstart this reaction, you need to provide some energy, and that energy is provided by the burning of magnesium in air because it's highly exothermic and therefore it releases a lot of heat that is used to jumpstart this particular thermite reaction, which is used for welding as well as it is used in metallurgy to extract metals from their corresponding oxides. Okay. Apart from that, the other metal oxides are usually not produced by burning them in the corresponding air, but rather they are formed by the thermal decomposition of the carbonates. So, for example, calcium oxide is produced by the thermal decomposition of, that means when you heat calcium carbonate, it forms calcium oxide and the carbon dioxide gases evolve. Okay, so uh, this is now you will ask me why this is so, how like you are able to so easily decompose a carbonate to form the corresponding oxide. That is because when we talked about lithium compounds, lithium being less basic, like lithium hydroxide, lithium oxides are less basic. So whenever you have the basicity reduced, then the corresponding oxide also salt, they actually can decompose on heating very easily. So group 2 oxides are less basic than group 1 oxide. So probably that is one reason why carbonates can easily decompose on heating to give the corresponding calcium oxide, and the carbon dioxide gases are therefore released. Now let us move forward, and so let me go back. So let me erase whatever I have drawn in here, otherwise it will keep coming in the other slides as well. So talking about now the calcium oxide is also called as, if you remember, it is from your uh, school, calcium oxide is also called as quicklime. Okay, and the quicklime is produced in industry in large scale because they are used to produce calcium hydroxide. Okay, in various ways, calcium hydroxides are useful. So we usually prepare quicklime in very large quantities. Now, talking about these characteristics of the metal oxides, this magnesium oxide and barium oxide, they are used as linings in the furnaces. That means big furnaces, when you make the linings inside the furnace is lined with these oxide. Now, why you use these lining is because of their property, like they have a very high melting point, they have a very high melting point. Okay, a very high melting point, and then they are very good conductor of heat. They are very good. My writing is not that good, but it's okay. Very good conductor of heat, and they are chemically inert, and they are also electrical insulators. So all these combined property is what is helping as to use these two oxides as linings in the furnaces. So quicklime is also industrially very useful, so it is synthesized in large amounts. Apart from that, magnesium oxide and barium oxide, they have these properties which make them useful for lining the inside layer of the furnaces. Apart from that, usually the oxides, as we saw in the case of group 1 elements also, when you react oxide with the water, they form the corresponding hydroxide. Similar to that, the group 2 metal oxides as well, when they react with hydrogen, they form the corresponding magnesium hydroxide. So magnesium oxide, when you react, it forms a weakly basic magnesium hydroxide, and since they are weakly basic, they actually used for treating acid indigestion in our stomach. So some of the medicines yeah, contain this magnesium hydroxide for treating acid indigestions. Okay. However, the calcium oxide, strontium oxide, and barium oxide, they react with water, and they form the corresponding hydroxides. And this reaction, that means the reaction of calcium oxide with water to form the corresponding calcium hydroxide, that reactions are pretty exothermic. So all these red colored elements, that is calcium, strontium, barium, all their oxide, when they react with water, this reaction is very exothermic. Okay, so that is why I colored them in red. So all their oxides, when they react with water, form their corresponding hydroxide. These reactions are highly exothermic in nature. Now, when we talk about the beryllium hydroxides are kind of very less basic. However, they are more amphoteric in nature. They are amphoteric means they react with both acid and bases. So here I have written down a point that your barium hydroxide, they are soluble in excess hydroxide. Now, why beryllium hydroxides are soluble in an excess OH is because they form a berylate complex. Like I'll show you here when you react beryllium hydroxide, that is BaOH, twice. When you react this with excess of OH minus, it actually forms a berylate tetrahydroxy berylate complex. So this is B, okay? B, E, okay? So you form a complex which is actually nothing but tetrahydroxy berylate complex, okay? And this is sometimes also written something like this: BeO2 with two molecules of water, okay? 2 minus, okay? So this, so this or this, okay? So basically this is tetrahydroxy berylate complex, or you can simply say as berylate, okay? So because these are soluble ions, uh, that is why when you uh, treat beryllium hydroxide with excess of OH, they become soluble because of the complex ions that are produced in the solution. So basically you have to here add 2, so it will be balanced. So that is why beryllium hydroxide gets solubilized when you treat them with excess of hydroxide ions. Okay. Now let's erase this because again it will come. So I hope you are writing it down. So if you have any doubts, we can discuss them in the live sessions. Okay, let's move further. So ease of formation of, now we are talking about peroxides. Now how peroxides are formed. If we talk about the ease of formation of peroxide, we know that the stability of the peroxides increases as we move down the group. So down the groups, the size of the ions, the metal ions are increasing. Therefore, the ease of formation of peroxide also will increase as you move down the group. So ease of formation of peroxide will increase because of the increase in size of the ion. Okay, so stability of the peroxide ion increases as we move down the group. So therefore, we have the formation of calcium, strontium, barium, as well as magnesium peroxides also possible. But beryllium peroxides are not known because of their instability. Okay, so let's discuss how they are made. So barium and strontium, they are actually made by heating uh, in air the corresponding metal oxides. So barium and strontium can be made by heating the metal oxides, their corresponding metal oxides in air. So by heating metal oxides in air, you can form the corresponding peroxides. For barium, the temperature to which you heat is 500 degrees centigrade. However, in case of strontium, you require high pressure and temperature. So you just heat their oxide and you get the corresponding peroxides. Okay. Now, calcium peroxides are usually formed by this reaction. How it is done is that you take the hydroxide and you treat it with the hydrogen peroxide to form a hydrated form of calcium peroxide, which on heating get dehydrated by the loss of two water molecules. Okay, so you have here the loss of two molecules happen, water molecules happening, and you get the corresponding calcium peroxide. Okay, so this particular methodology where you treat the hydroxide with the hydrogen peroxide to form the hydrated form of peroxide and then dehydrating by heating to get the corresponding peroxide is also done in the case of magnesium peroxide. Magnesium peroxide also, if you want to synthesize, you will take the corresponding magnesium hydroxide, you treat it with hydrogen peroxide, form the hydrated form of the peroxide, then you heat it and dehydrate to form the corresponding magnesium peroxide. So these are the ways in which you form the corresponding peroxides of these metalides. As I told you earlier, peroxides are not known because of the instability of the peroxides of beryllium. So beryllium usually forms only monoxides. And talking further, you have here another reaction which says that when you heat metal peroxide with acid, they form the corresponding chloride and hydrogen peroxide gases released. So this particular reaction we also know because in group 1 also, any peroxide, when you heat it with acid, they will release the hydrogen peroxide and form the corresponding chloride ion. So this is all about the various reaction that group 2 metals undergo with the group with the air and their corresponding oxides and peroxides. Now, you can read about it from J.D. Lee. It's given in page number 338 till page number 341. So I have already uploaded that. So you can see there and get hold of this particular portion. So I hope you understood pretty well this thing. We will talk about more about this in the live session. Whatever you have whatever doubts you have, please make sure you write them down, and we will discuss everything in the tomorrow's live session. Thank you very much for your attention.